Let's take a look at this integral now. You notice sometimes you need to think about what technique to use, but here we're going to use substitution because notice if we let u be the thing in the denominator under the fourth power there, namely t to the 3/2 minus 4, then the derivative of this is what? It's 3/2 t to the 1/2. And look, I have a t to the 1/2 right there. It doesn't have a 3/2 in front, but that doesn't matter. We can fix that. So the fact that when I take the derivative of what I let u be, the fact that it's somewhere else in the integral is a real clue that that is a good choice to proceed with. If I would have let u be root t, let's say I did that over here maybe, the derivative of that would be 1 over 2 root t, right? And notice this expression here doesn't appear at all anywhere else. So that would mean that this would be a bad choice. So we're not going to do that. This one is going to do what we want. Let's see what happens. Du is 3/2 t to the 3/2 minus 1, which is 1/2, minus 0, and then we multiply by dt. Now, on this integral here, I do have a root t dt, which is the same as t to the 1/2 dt. So I kind of have this here. But the 3/2 is not, we don't really want that there. So why don't we just multiply both sides by something good to get rid of that 3/2? Well, we should multiply by its reciprocal, right? Let's multiply both sides by 2/3. 2/3 times du is what I have on the left side. And on the right side, 2/3 times 3/2, that just gives, what, 6 over 6, which is 1 over 1, which is 1. And so it kind of just disappears. So I have 1 times t to the 1/2, but I'll just write t to the 1/2 without the 1 in front. Same thing. And this is what I want. Let me just do one clarifying step here. Let's write this as 1 over t to the 3/2 minus 4 to the 4. And then times, instead of writing root t, I'll write t to the 1/2 dt. Okay. Now, I can do my substitution now. This t to the 3/2 minus 4 is just a u, so this is u to the 4. T to the 1/2 dt, well, that's just equal to 2/3 du. And there we go. We know we have a successful substitution because there's no more occurrences of the old letter t. Everything is now in the new letter u, the new variable u. Let's bring the 2/3 to the front. And instead of writing 1 over u to the 4, let's write u to the minus 4 du. And now we have an easy integral. This is just an integral of a power. We know how to do that. The integral, if we add 1 to this, we get -3. Think of this as -3 over 1. We flip -3 over 1, and we get 1 over -3. How about I put the negative on the top, though? Same thing. Plus c. This is an indefinite integral, so I remember that. Multiplying these out here, I get -2 over 9. U to the minus 3. Why don't I bring the u to the minus 3 back down now to get rid of the negative exponent? And I get that. And really all that's left to do now is to replace the u by the original letter, which was t, right? Remember, u is just t to the 3/2 minus 4 there. So we'll just put that in. Whoops. We'll just put that in. T to the 3/2 minus 4. We get something like that, and that is our final answer. Okay, so not too bad. Let's finish this one off and see you in the next video.